Good. All right. So 4-7, here we go. One is a thing called valence electrons, VALENCE electrons. VALANCE is a similar but not meaning at all the same word. What's the VALANCE? Know that one? Has to do with home decor. It's like curtain stuff of valence. So that's not what we want to spell there. We're trying to go valence electrons. 2, you could go with core, or you could go with kernel, Kernel, not a COLONEL, kernel like the Army, but a KERNEL like a popcorn. So core or kernel, take your pick. 3, 4, 5, in no particular order, we can either gain electrons, or you can lose electrons, or you can share electrons. All of those things will happen over time. 6, what we're trying to do is obey a thing called the rule of 8, also known as the octet rule. So you could pick either of those sayings. But electrons like to have, or atoms like to have 8 electrons. So if it only has 7, it's going to try to go and gain 1. If it had 9, it would rather lose 1. But if it had 7 and it ran into somebody else with 7, they might be better off to get up to 8 by each.
Looking for someone with 9?
No.
Sharing?
Sharing 1. So if I have 7 and Caleb has 7, and we both share 1 with each other, so we're sharing 2 total, but sharing 1 apiece, that would be another way we'd get to 8. I'd have my 7 plus 1 he shares. He'd have his 7 plus 1 I share. But we can play electron games by either gaining them, losing them, or sharing them, but the goal is always get to 8. 8 is the magic number of electrons. Question about top group of what you read? Yeah.
Does rearrange count as shared for number 5?
I'm going to say yes for a day. That's a similar word. More first 6. Then stuff that everybody has. So units is AMUs, is, was, and has been on all of these quizzes. It's carbon 12, it's 12 AMUs, it's Dalton. Then we have this category thing of protons, neutrons, electrons. Protons are P plus with a positive 1 charge and a 1 AMU, and that's in the nucleus, probably in a picture. Neutron is N0, that is neutral or no charge, that's 1 AMU, also in the nucleus in your picture. Electrons is E minus, that's a -1, that's a negligible mass, and that's floating around the nucleus in your picture. And then the other stray point is labeling the nucleus is worth a point. So if they forgot to label the nucleus, they'd be out 1. Then there's questions that I shuffle every day. So the mass number question, depending on which quiz you're grading, whether that's first or second, is a little bit varied. But the mass number is adding the protons and the neutrons. The atomic number is just the count on the protons. And then we all have the same stuff. Ions is an atom gaining or losing electrons. Energy levels are a series of areas outside the nucleus where the electrons are. And then I'll just stall out and pause for a minute. Anybody need some help in scoring any of that business? I think we still all match each other with makeup quizzes and live quizzes. Isotopes have same atomic number but different mass numbers. What causes that is different numbers of neutrons. What's true for the properties, chemical is same, physical is different. The why are they not whole numbers is because they're averages. And then I think some people's quizzes are done at that point, right? Is that where that wraps? Yeah. And then other people, we keep going. The keep going crowd, we've got Niels Bohr, we've got increase, we have 7. This way I did this question on 36 is emit, but if I switch to go up to a higher level for a future quiz, that would be fair. You just go with the, not emit, but what word? Absorb would be on my best word. 37 has to be a vacancy, just like trying to stay in Ocean City at a hotel. You need a vacancy to make the move in.
So 1 and 2 on the old quiz. What would that be?
1 and 2, oh yeah, good call. So 1 on the old quiz was attract, 2 on the old quiz was energy levels. Question about scoring that? Did anybody have questions about homework, anything up to and including 13? If you have any of those papers on hand, just send those. And then let's do some homework-y type new stuff. So the main part of the homework tonight is going to be writing a thing called electron dot formulas. The electron dot formulas are going to be representative of the electrons at the highest level. What were those called? The valence electrons. So here's a bunch of elements. Grab a periodic table, and this will help us out. So hydrogen. How many electrons does hydrogen have? 1. How do you know that hydrogen has 1 electron? Because it's the atomic number. The atomic number, though, I thought was counting the number of protons. But they're the same. Okay, so if you look at the atomic number on the periodic table, everybody grab a periodic table or grab a book and open it to the front cover. But hydrogen is atomic number 1. That means it has 1 electron. So your job is about as easy as it gets to draw an electron dot notation for this. You're going to write H and put on it a single dot. How many dots did we desire? Most of the time 8. So they explained in the reading how you would show this if it had all 8. How would you show it if it had all 8? 2 on each side. Imagine it's like a square table. We're going to put 2 on each side of the table. For this, we're putting a single dot. Doesn't matter which side you put the dot on. No. So you could do it on the right, you could do it on the left, you could do it on the top, you could do it on the bottom. It doesn't really matter. Just put a dot. So there's your simplest electron dot formula you could ever do. And then let's move on to helium. Helium is atomic number 2. So that means it has 2 electrons. Usually when you have 2 electrons, you go 1 somewhere and 1 somewhere else. But they told you for helium, do them as a pair. It doesn't matter which side you do them on, but instead of spreading them out like you would usually do, put helium as a pair on one side. Reason being, to fill energy level 1, how many electrons does it take? 2. So since that's a full energy level and they're at the same level, they just want you to do a double dot on one of those sides. Lithium is number 3. So I am not going to do 3 dots. Why for lithium am I not doing 3 dots if it has 3 electrons? Because they're not all valence electrons. 1 is a valence electron. 2 electrons went in to fill level 1, and now that 3rd dot is at level 2. So we only have 1 valence electron. So I'm going to just do 1 dot. It doesn't matter which side you put it on, but my habit, for whatever reason, I just start off throwing them on the right. I don't know why, I just do. There's no real reason for that. Boron. How many electrons does boron have? 5. But not all 5 of those are valence electrons. How many aren't? 2. Because 2 of them were at level number 1. We're doing 3 dots because we have 3 valence electrons. So I'm going to go 1 on the right, because I always just use the right, I can't help myself. And then I'm going to spread these out, and I'm going to go 1 on 3 of the 4 sides of this boron thing. You spread them out as evenly as you can. I suppose you're trying to simulate what the electrons are doing. Electrons have what charge? Negative. If you have 2 things with like charges, what do they do to each other? They repel. So they would naturally try to spread away from each other, and I think that's what we're trying to simulate with the dots. Nitrogen, total electron count is 7, because it's atomic number 7. How many don't count? 2. So we're going to go 5 dots. 1, 2, 3, 4, and then create a partner in your favorite part, which for me will always be on the right, because I'm just stuck in a rut like that. So I'm going to go a pair, and then single, single, single for my 5 dots. What's P stand for? Phosphorus. Phosphorus is atomic number
15.
15. All right, so then we need to have a break and have a discussion. So how many electrons does it take to fill the second level? 8. But not a total of 8.
10.
Grand total, we'd be up to 10, because it took 2 to fill level 1, and 8 more to fill level 2. So it takes us, the first 10 electrons on this count are filling levels 1 and 2 combined. So if phosphorus has 15, we only care about 5. So I'm going to go double, 3, 4, 5, 5 phosphorus dots. Chlorine, number 17. So we care about 7. How are we going to do 7 dots?
4 around and then 3 double up.
Yeah, 3 double up. So I'm going to go double up, double up, double up, single up. Argon
18.
is 18. So we care about 8.
So double.
Double everybody up. That's as many dots as you can do. You can't do more than 8 dots. It's impossible to ever have more than 8 valence electrons. It can't be done. I'm not going to tell you yet how many electrons it takes to fill level 3. That's going to be a lesson maybe for tomorrow, because what I referenced the other day is what starts to happen.
A lot of dots.
Yeah, but
They like split between levels.
it goes, some of them are going to go to 4 while others go to 3, and they're going to like fight it out. And you might be filling 3, 4, and 5 simultaneously, or 3, 4, 5, 6, and 7 simultaneously. There's an order in which they fill, and that's what tomorrow's lesson is. So today's homework, I don't think they can give you a number higher than 18, because you don't have the background information to know, once you get beyond that first 10, what's going to happen. So just wait and see on that. But yeah, the highest number you see in the homework tonight is an 18. It's argon, which I already did for you for free. So hooray for me and you both. Here's something else you can do. Periodic table shortcut. Does anybody know how argon, we could have known there was 8 without math? Strictly looking at the periodic table, not doing math. It's what? That's true. Yeah. Okay, track up, find argon in your table, track up to the top. It is in Roman numeral 8. That means it has 8 electrons. Chlorine is in Roman numeral 7, so it has 7 electrons. Phosphorus was in Roman numeral 5, so it has 5 electrons. Looking just at the Roman numerals, not the regular numbers. So the N is Roman numeral 5, so it has 5. Boron is Roman numeral 3, so it has 3. Lithium, Roman numeral 1, so it had 1. Helium, Roman numeral lie. Helium's always a lie. It's in Roman numeral 8, and it lied to you, but helium has 2, so never trust helium. Hydrogen, Roman numeral 1, it had 1. But other than helium, the Roman numeral will always tell you the number of valence electrons. So that is one of a lot of really interesting features of the periodic table. So either do the math, which is how we came in, or just use a Roman numeral. Roman numeral will always tell you valence electrons. Other than helium, helium always lies. Although it does make your voice funny. So, you win some, you lose some with helium. Question about doing these electron dot businesses. Okay, so here's the homework tonight. Homework tonight is 14, 15, A, B, C, D, E, F. So there's 12 of those, but that shouldn't take you long. We did 8 there in slow motion and took about 3 minutes. But 14, 15 is the main game. There's also a 2B, and I'll avoid making a Shakespeare pun. And there's a 1M and a 1N. So 1M, 1N, 2B. Oh, so hard not to make a Shakespeare pun. And 14, 15, that's the homework for next. Read for next is 4, 8. So 4-8 is gonna come out of the gate with an 8-point question that should be pretty obvious. There's like, it's just there. There's like a package of 8. There's like 4 pairs of facts to make 8 points. So we come out of the gate with an 8-point question. And then there's one other question that's not in a margin. It's just like there. Just read it, see if you can find it. Maybe it's in italics or something. I don't know. But 9 total new points, a group of 8 that should stand out, and a single point. Then I do probably some trimming, because this is only going up to 35, so something's got to go. So let me compare and contrast a little bit. Compared to today's, 7 through 10 is a keep. I ditched the 15-point question. I guess I've had enough of that. Then it looks like I'm keeping everything else. Compared to today's, 1 is a keep, 2 is a keep, 3, 4, 5 is a keep, 6, you just need the number. How many electrons do we want to have? 8. New question, which atoms naturally have that 8? Natural having of 8 is noble gases, NOBLE gases. That's why the noble gases don't play with other elements. They don't react, they don't do anything. They have their 8, so they just like stay home and hide like little element hermits. They're not coming out of their cave. They got their 8 and they're out. They're not going to share, they're not going to give, they're not going to gain. They got their 8 and they're retired and they're not coming out of the house. And then I do need to tell you the question mark answer here. So first energy level is a question, say 2. Second energy level, say 10, because 2 plus 8. Third energy level is going to be 28. So I do need to give you that number a day ahead of time. But to fill all 3 energy levels takes 2 plus 8 plus 18, makes a total of 28. Question about quiz breakdown.
What's leaving?
What's leaving is that massive question that was 15 points.
And that's it?
And that's it. So I ditched all of that. I kept everything in. I'm a little surprised I didn't ditch the ones older than that, but I guess I was young and foolish when I made this quiz and just left those on there, because I feel like AMUs, we've had enough AMUs. We don't need to really answer carbon 12 every day for the rest of our lives, but it's some free points. It's not a bad thing. If you're still missing like Dalton or the 12 AMUs, I don't even know what to say to you. Yeah, it's just bad. It's bad news bears.
For the homework specifically, something like neon that has 10, do you just put no dots?
No, neon doesn't. You can't go above 8. So neon, you don't count those first 2. Neon is number 10, but the first 2 were used up at the first energy level. So you're worried about the other 8, and it's in Roman numeral 8, and that's another way you could know that it has 8. So you're going to do 8 dots. Yeah, we can't. If you ever get anything higher than 8 dots, something went wrong with the strategy. Anybody else? Question about 4-8, question about scoring quizzes, question about getting homework done. Okay. All right, so that's a wrap.